Hello, welcome back again to my tutorial channel. So this channel is dedicated for all engineers to get better knowledge and skill while using CAD, CAE and CAM software. So in this tutorial, I will bring to you FTI FormingSuite. This is a software for metal stamping simulation. In this example 3, I will show you how to create manual Flange feature, 3D Addendum until we create the costing simulation. Now this is the summary of the simulation. In here, there's a part and I manually assign this as a flange. So this is the color coded. The flange color is in blue. So this one is highlighted in blue. And then after this, I try to unbend or unfolding this flange and then create the 3D addendum. After I create the addendum, then I go to validate the product design. For example, to find the thickness, the thickening and also thinning effect and so on. And validate the product itself using FLD or forming limit diagram and then goes into nesting. And finally, I create the operation starting to OP20, 30, 40, 50 and 60. So at the end, it will create a costing simulation. In this video, I will demonstrate how to create stamping simulation using FTI FormingSuite. So at the beginning, we're gonna click new to create new project. And then, as usual, going to Tools, Unit, I will change the unit force from Newton become ton force, and also remove the decimal place. And also, if you want to change the currency, you can go into the currency. There are several options for each country. What you prefer, you can select this in here. For this tutorial, I only use the default in the US dollar. And then I'll remove the decimal place. Okay. Next, we will import the geometry. So in here, we still use the example geometry. It came from the installation folder. The location is on Windows, Program Files, FTI, Geo folder. So we're gonna use the example geometry. In here, it's called lower back. Click Open. So this is the part. Now before I continue, I will explain a little bit in here. On the left, we see in here, this is the location where the geometry came from. And in here, we have a 3-set geometry, set 1, set 2, and set 3. So what is set 1, set 2, and set 3? Okay, let me zoom in. This is only a surface without any thickness. Okay, so the geometry set 1 is the top. Geometry set 2 is the thickness. Geometry set 3 is the bottom. So when I click this one, for example, going to path, now you can see the geometry have its thickness. Now this thickness will be automatically read by FTI FormingSuite. So it means when you add the material or you define the material, the thickness will be automatically read and put in the dialog box. Let me show you. For example, if I click the measure and then I measure in here the thickness. The thickness is 1.5 millimeters. So this will be automatically read by FTI FormingSuite. Now in here for the simulation, I will use only one surface. Maybe I will just use this geometry set 3. It doesn't matter whether you can use geometry set 1 or set 3 because the thickness is automatically read by the FTI. The thickness direction will be not asked by FTI. So we do not need to assign where the direction of the material thickness. So in here, I'm going to use geometry set 3. And then next, I'm going to define the material. Now you see in here, the material thickness is automatically put in 1.5 millimeters. Maybe for this material, I will choose maybe this one, JS H550R, and then I go into properties. So this is the mechanical properties of the material that I already select, and this is also the FLD, forming limit diagram properties, and then this is the cost. So in order to get the costing simulation, you must enter the value. Maybe in here, just for example, I will enter this one as a 15, maybe this one as a 4, this one as 2, and this one consumable only $1. Click OK, and then I can click OK. So now we have the material with the thickness. And then next, I will fill in this hole. Fill holes, select all. So it's gonna be highlighted like this one. And then you can click OK to fill the hole. So this is the line that fill the hole. Okay. Next, I will apply direction vector that's gonna be used for the forming simulation. Several options in here. There is a normal to picket point, auto, manual, screen view, and axis. So if we see in here, the geometry quite complex. There are a lot of different surface. So if you found the geometry like this, it would be better. You use the auto and then select the average normal. So in here, it means the FTI FormingSuite will automatically calculate all the normal direction factor and calculate the average for all those factors. And then also, if we choose this one, we have this tool. We can check is there any undercut. No, we don't have any undercut. If we have, it's going to show in the red color. And also we have option to check the draft angle. So this is draft angle analysis. And then the third is trim condition. So in here, the trim condition, we have read this one. So maybe for simplification, we will assign this as a flange and then we unbend this one. Okay, this is what this is looks good. We click OK. Now we're gonna create what we call a part feature. So we're gonna use the manual function. Actually, there are two types: the automatic and the manual function. In here, we're gonna use the manual function. So in here, we have a lot of option. In here, the dots, embossment, extrusion, first form, and flanges. So each of the feature is color coded. You can see in here. Okay. And for example, if I select flanges like this one, and I pick this surface, so to make easier, I can use the box selection like this. So it will select all the surface, and then I can click OK. This one. So it means this color is a flange. Okay. And also there's an option like this one, but it's called show unfolded flange. So when I click, the software will automatically calculate the extended surface for this flange. It will unfold it. Yeah, this is the result. This is the unfolded flange. This one is curved in here. Okay. So next, we're gonna create the 3D addendum. But before we continue to the addendum, it must have what is called a binder. So we're gonna create the binder. So when we create the binder, make sure you adjust first the view. So in here we have a three option: the punch direction side A, and punch direction side B. So we're gonna use punch direction side A. There is the option flat and silhouette. Okay, let me show you for the flat first. This is the preview. Okay, let's go back again, the punch selection side A, and then I can clear view to change silhouette, and then click the preview. So this is automatically it will create this silhouette. Now in here, in order to create this binder, you can adjust using this arrow in here, and the guidance is you must create so the binder in here is like enclose the geometry, so it's like being hugged by the binder itself. Okay, so this one I think is pretty good. Maybe I can put a little bit. Okay, okay, this one is good, and then I can click OK. Now please add the gap in here, for example -10 millimeters. Click OK. So this is the binder that's gonna be used as the base for 3D addendum. Next, we click 3D addendum. So this is the geometry. Roll back geometry set. This is geometry set 3. Okay. Direction vector we already defined, and then you can click OK. The next is we're gonna create path extension curve. Now in here, remember we already create unbend this one in here. Okay. So yeah, let me click OK first, and then I will show how to modify this curve. Now I will create a radius for each sharp edges using the smoothness, and also reduce the complexity of the curve itself by make it a little bit less complex. Okay. Okay, the curve offset maybe I will add become 10. Okay, now this one. Okay, and then I can click OK. Now in here I have something unfolded flange, so let me show. In here, show unfolded flange. Now please notice in here the surface unfolded flange is crossing the binder surface, so it means we must edit the binder curve in here. Okay, like this one. You can go back, maybe change a little bit like this. We change the convexity like this one. Okay, can click OK, so it will automatically created. And then if I go back to addendum, okay, in here we have it's called path extension curve. I can show again. This is the unfolded flange. So now it's not intersection with the binder surface. Now we're gonna edit the path extension curve. So this is the path extension curve, and I'm gonna show the unfolded flanges in here. So what the main goal is to make sure the path extension curve have a gap about 10 millimeters like this one if we measure from this curve. So it means we have to extend it in here become 10 millimeters gap. Okay, how to do that? First we must change the view with the punch direction, and then after that there's a tools what it called edit curve. We click on this curve, and we click slightly on the in here on the straight line, the start point and also the end point is quite far in here. So when you pull it, it's gonna be like this. So in here you can see if there's enough. This is 10 millimeters, and also this seems like 10 millimeters or not. So you can see in here, if I change a little bit, so if I click this one, make it smooth like this one. Okay, this enough. I think this about 10 millimeters if we measure from here. Okay, and then also I can click OK for this first. Also, I will edit this one also. So the start point should be on the straight line, and also go the end point quite far on the straight line also. Then I drag it. So yeah, make sure it have a approximately, right. This is 10 millimeters, so this is approximately by my view is 10 millimeters, and then I can click OK. So now we have two in here, and now as the third step to edit in here, okay, I'm gonna click first in here the peak of it. So the peak maybe in here as a start point, and the peak in here as an end point. So in here I will reduce the tension, so it's gonna be straight line, the middle also straight line, the end also straight line, and then I drag this, make it smooth, and approximately is about, yeah, so we must keep the distance as good as possible. Okay, so as if it has a gap about 10 millimeters. So I think this is good. You can click OK. So this is how to edit the path extension curve. Okay. So this window, even I already complete, it still appear. Why? Because I lock this one, keep visible. So it means when I this one I click cancel, so it will not like that. Okay. Now I have this one. So the next step is click this green arrow. We're gonna create die radius. So this one has a projection curve into the binder surface. There's a draft angle 6 degree and the fillet radius 8 millimeters. And then we can check again the smoothness. Make sure it will smooth and remove any sharp edges. And also we're gonna remove the convexity. Okay. Please notice, do not use this smoothness slide bar and convexity slide bar too far to the right, because it's gonna be totally different from the actual geometry. Okay, click OK this one, and then we're gonna click the die face. So there's an option in here: punch radius, die radius, edit proportionally, and adjust of angle. So I usually use this one in order to maintain the consistency, the punch radius, die radius, and all draft angle in every location. Okay, now we get the die face in here. Next, we're gonna create the trim lines. So the trim lines, we have to in 2D, we click generate. This is the trim lines. Remember, this is the extended surface from the flange. So this is the trim lines. Please notice we have two colors in here. The first is green, which means we can directly trim, and the second is red. It means we're gonna must trim it using a cam. And there's a slight in here a little bit. The color yellow is marginal. Okay, it's good. Click OK, and then create now what is called boundary trim. So in here it will trim out the binder surface. Please check again, is there any sharp edges? If no, we can continue. Then finally create the first form. Click OK. Okay, now we found our first form. We can extract what is called a tooling in here. create tooling. So if I click, now the software create what's it called punch, blank holder, and also die. So each of it you can export, okay, become a CAD file in the IGES format. Okay, blank holder also you can export, die also you can export. Okay, after finish this, the 3D addendum, so the next step we're gonna do the process setup. This is the maximum element size recommended by FTI FormingSuite. Because in here we found several complex geometry in here, maybe I'm gonna make it smaller, become 10 millimeters. Okay, this is the meshing result. Okay, you can see also the element distribution. Okay, and then when I expand this one, show detail, you're gonna see in here the code deviation and the maximum element size. Okay, next we're gonna define the punch direction. We gotta use the direction vector that we defined before this, and then maybe we can check again about the undercut, something like that. You see in here, okay, it's good, there's no undercut. And how about draft angle? This is the analysis of the draft angle. Okay, and then the third is the term condition. So the term condition like this one. Okay, okay, good. Next we're gonna define the forming process. There's the option form, draw, and auto. But in here, FTI FormingSuite tells you this is draw. So it will automatically select in here. But if you don't know, or maybe you're not certain, you can select auto. So and then click OK. Next, we're gonna solve the forming calculation. Now you see in here, there's two result, the flat blank and the final form. So this is the final form, okay, and this is the flat blank, the green one. Okay, before we continue into nesting using this flat blank, we're gonna see the final form first. So in here, we can see the report about safety zone. You can see in here most of it is a green. In here we have a several location. We have excessive thinning, but is there any split? It's not appear. Okay, maybe we can continue with the forming zone. We have in here the type panel in here, in here. So yeah, we have a strong wrinkling tendency. Okay, so in here also we can continue to safety margin. Let me click in here. What is the maximum and the minimum? Minimum and maximum is in here outside the product. Okay, but is above 1 and is near 0. Okay, maybe this we can check more. We can go into the thickness strain. So this is the thickness strain. Show the min max point. Okay, the minimum is minus 28.6, the maximum is 13. So it means that it's gonna be strongly possible wrinkle in here, and also maybe gonna be strongly have a crack in here. Okay, so it means we have to change a little bit the 3D addendum shape in here by modifying the curves in here. Okay, so that is the solution. Next, I will show about the thickness. Okay, this is the thickness. You can see in here, minimum is almost 1 millimeters. Meanwhile, our default thickness is about 1.5. So there are excessive thinning in here. That's why it's gonna be crack in here. And also in here, there's possibly a wrinkle because our default thickness is 1.5. Meanwhile, in here is almost 1.7. Okay, so it means we have to edit this 3D addendum. For this tutorial, I will not edit this 3D addendum. I will continue until finish. We have the costing simulation. Okay, now we continue to the next step, but it's called a Springback report. So this is a Springback calculation. I can click this one to solve, and also I can click this one. The green button is the same. Just both are solve. Okay, this is the reports of the Springback. We can see the magnitude, and you can see the deflection. So uh, in order to get the better understanding about what is the Springback report, maybe I will go into this one, shape, okay, and then you can click this one as a reference of measurement. Click this, and maybe click this, and the third you can click this one. Okay, there's a 3 point for the data measurement, and then show height path. Now notice in here there are Springback. The gray is the original and or the reference. Meanwhile, the green is the finished product after stamping. So in here you can also do the measurement here and also in here about 2.35. I measure the exactly same element this one. So make sure when you create measurement the element should be the same. So you're gonna have the correct answer for the Springback like this one. Okay, and then I also can do the calculation what is called Springback after trimming. So this is the Springback after the final product. I'm gonna do is copy first and then rename it as Springback after trimming. So this one, click OK, and you modify the input. Use trimming and select the curve like this one, and then click OK. Next is regenerate. So we calculate using the final product. So this is the Springback report after trimming. Like this one. Okay. Now after we finish do the evaluation for the product, we going into the nesting. So when we gonna do nesting, first we must go into the flat blank. This in order to create what is called blank definition. So this is the blank. Okay. This is the blank. And then we can do the next step is create nesting and strip nesting. First I'm gonna go to the nesting. So we're gonna get the reference, the width of the coil we must use. Okay, the distance between is 4.5 millimeters in point A. So this is the between parts, and in the point B, this illustration is also 4.5 millimeters. Okay, next. In here, we're gonna calculate all. Now we have this report. We have one up, two up, mirror, and cut-off dies. Let's see which one is more efficient. One up, 88.9 material utilization, about 60%, cost per blank 108 US dollar. Okay, but two up is much more efficient. The efficiency is about 91%, it's almost 92%. Okay, the cost per blank 105 US. The mirror also 91.95, so almost the same like two up. Cut-off dies only 88. Okay, maybe we can use two up. So in here, it means that if you have a coil or have a sheet metal, at least you must have a width about this one, 1250 millimeters. Okay, so this is going to be used as a guide reference when we create the strip nesting. Okay, let's go back to blank and then go to strip nesting. So in here, the default is 1250 millimeters. The length is 2500. Okay, this is the default. Maybe I can change it a bit, become maybe about 3000 along width, and then we can click this one. Also the gap still same. Click next step. We can solve all. Okay, no metal cut, different parameters. Okay, okay, so it means we only have this one up step layout, materialization this very low, to up also quite low, mirror, yeah, number 4 cut of dice is this one. Okay, so yeah, I think the efficiency is what average about 51. Yeah, 51. One up, two up, and mirror give the same efficiency. Okay, so it means you can select whether you can want to use one up, two up, or mirror. Okay, now we can continue to the line die plan. This is a line die plan. We activate this one up, so it will revert into one line. One up, create line die plan. So next is define the blanking setting. In here we have two options, the purchase and offline. So if you cut your own blank inside your factory, you can select offline, so it will be included in the price calculation. But if you purchase from the vendor supplier, so it will be excluded from the costing calculation. So in here it means maybe I'm gonna check this one, the purchase, as if we buy from the vendor. Click next step, click generate part feature. So this is part feature that we already defined before at the beginning of this tutorial. We have a plans in here and the first form draw in here, and also we have a trim lines. This is trim lines, the red one, and this hole also. Next is the process. The process we're gonna use transfer type. Okay, the blank we process only one. Okay, so one blank each time we process. Then for the other parameters we can accept this. Click OK, and then for the blank position you can based on minimum fit, based on the next gen layout. Okay, and also you can do manual and do the rotation like this. Okay, maybe I'm gonna do the rotation like this, and then I click OK. So next step is generate die line up process. Because we purchased the blank, we don't have any station to cut the sheet metal and create the blank. So it will directly go into OP20, 30, 40, 50, and 60. Now in here, we can see this is OP20, OP30 is trim this one, 40 trim this one, OP50 only this one. So it means we can move into maybe into OP40 is okay lah. Okay. Now in here we have OP30, OP40, okay, OP50, no operation in here, no process, so we can delete the operation. The OP60 is flanging, okay. Okay, we click this one to validate the process. So it says there's interface between part feature, so it's just a warning, we can continue. Then we can save the process. Next, we can go to the summary. So this is summary of the process. This is OP10. The blanking is purchase in here. Show you. Okay. So in here we just only have this one. Almost there's no other value. Just only pitch and width because this we purchase. Meanwhile in here the process is the summary for all the OP20, 30, 40, and 50. So the die load tone force is the total for this one plus this plus this plus this. Okay. Now in here there's also information in here is what they call the severity level. So severity level in here is low, so it means easy to create or easy to manufacture. In here also low, low, and low. So all the OP in here there is no issue about the manufacturing process. If you found the severity is high or severe, you must expand the operation. Okay, so in here we found low, so this is okay, this is good. And then we can go to cost breakdown. You can see in here the blanking purchase is excluded from the calculation because we purchased, there's no operation in here. Meanwhile in here we have the cost for the entire process for OP20, 30, 40, and 50. Design, machine, build, tryouts, material, and the total, transfer and fringes, also the grand total. And also the estimation how many hours to design, to machine this one, to build, tryouts also, and also the total hours. So this can be used as a guide or as a reference when you create a new stamping project. So that's it, the tutorial for FTI FormingSuite. I hope it's going to be useful. Thank you for watching.